All right, good afternoon, everyone, and welcome to parallel session C4 of our second day of the Philippine Economic Society 60th annual meeting and conference. This session is titled Economics of Energy, Economics of Disaster, and we have three papers lined up for presentation today. Our session runs from 1 p.m. to 2:30 p.m., but we hope to finish by 2:25 to give you ample time to move to the next parallel sessions that you would want to attend via Zoom. So our lineup are as follows. First, to present would be our colleagues from the University of Asia and the Pacific with their paper titled An Empirical Analysis of the Variance of Retail Pump Prices in Metro Manila, Baguio, Cebu, and Davao, authored by Maria Demetheris Eugenio, and of course our former PES president, Dr. Peter Lee Yu, both of the University of Asia and the Pacific. Next to present would be our colleagues from the Department of Science and Technology Region 11 with their paper titled Assessing the Vulnerability Factors Affecting the Economic Losses from Natural Disasters using a spatial autoregressive model in the Philippines, authored by Nathaniel David Abines and Ronald D. Estrada. And last but not the least is a paper authored by Jerwin P. Enerland of the University of the Philippines Visayas Tacloban College, titled An Analysis on the Economic Resilience and Vulnerability of Local Economies in the Philippines. So as for the mechanics of the presentation, each presenter will be given a maximum of 20 minutes each. Our secretariat will chat you if you have for the remaining, if you have reached the last 5 minutes of the allotted time, after which when all have presented, we will proceed to the question and answer part. So without further ado, let me now call on our colleagues from the University of Asia and the Pacific. You now have the floor.
Thank you, Dr. Cuevas. Good to see you again. I'm Peter Yu. I'm a faculty member of the School of Economics here at the UANP. My co-author is Ms. Thea Eugenio. She is now with the Department of Budget and Management, but she was with us here at the UANP when we started. Thea, can you share your screen na?
Yes,
and then you just have to advance the slides na lang for me muna.
There. Can you see it?
Can everyone see the slides na ba? No, I think so. No, I can see it. So I think there's no problem. So let me get started. I'll introduce the well, talk about the first part of our paper. Next slide, please. Yeah. Okay, well, that's just the outline. So next slide, please. Okay, so well, we are going to look at oil pricing in the, pricing in the oil industry. Of course, the oil industry oftentimes attracts a lot of attention when it comes to their pricing. There have been many studies in the past that look at pricing in the oil industry. And even actually globally, not just here in the Philippines, there's been one thread that looks at the question of the asymmetry, in the timing of the price adjustments. That means that the prices go up faster in response to increases in oil prices, and then when costs of oil comes down, well, there is some hypothesis that it does not come down as fast. So there have been many studies that look at that asymmetry of the price changes itself. Our paper looks more at the asymmetry, if there is any asymmetry, no, in the variance of prices. We'll explain a little bit why that was our interest. So it's we're looking at whether there is any relationship between the price changes and then changes in the variance or the spread of the prices. Next slide, please, Thea. So just very quickly lang, in the case of the Philippines, probably most are familiar that we came from an era where the industry was regulated and there were only 3 companies. And since the deregulation of 1998, actually, we've had a lot more industry players, and by some accounts, there's more competition as a result, no? So, but still, some interest remains about the conduct of the pricing changes. Next slide, please, Thea. Well, just as a background, the Philippines, especially now during the pandemic, you know, although in fairness, maybe to the company Shell, you know, they closed down their refinery. There's now actually only one refinery in the country, that's Petron. So everything else is imported. So everyone else imports there, including Shell, now imports oil products. And I was going to say, in fairness to Shell, actually, this is a trend that was already underway, even globally. I mean, Shell and besides Shell, there are other companies also closing down their refinery. Probably the pandemic may have confirmed or strengthened the decision of these companies, you know, to close down. But it's not just here in the Philippines. So everything is now imported. Oftentimes you'll hear a benchmark called the mean of Platts Singapore. This is essentially the average of oil trades conducted or at least monitored by Platts, an office, an oil industry price monitoring office. So that's kind of like a benchmark that's often used for this part of the world, especially for finished oil products. In our case, in the Philippines, you probably noticed that pump prices are normally adjusted on Tuesdays, you know, so and more or less everyone goes along. And so one question we had was whether or not as they change, you know, they tend to change together, but do they vary, you know, so that the price dispersion might be changing. Next slide, please, Thea. Well, I probably will dispense with this just to say that since everyone now is importing, except for Petron, who still refines, so they would import crude oil and then refine it into their finished product. Everybody else imports it. So I would make the basic cost components, you know, the product itself, imported product itself, and then the taxes, of course, the cost of shipping it here, and then exchange rate. Therefore, because it's imported, would be an important part, no? And for the case of oil products, there would be some addition then of either ethanol or biofuel. So yes, next slide, please, Thea. So we're basically, as I said, going to be interested whether when the changes in prices, if they are also accompanied by changes in the variances. I'll just go very quickly through next slide, please, Thea. We'll look at that price dispersion by the variance or standard deviation. I think we can move ahead, Thea, to the next slide. Well, I think Thea will cover na lang the data. So I'll let her in the areas that are covered by it. I'll just say that again, there are questions about even for the Philippines whether there is asymmetry in the price changes. One last, the latest study we can find by Abernica, which I think you can find published in the PES journal, actually found no asymmetry for the Philippines. But otherwise, interestingly, if we recall our next slide, please, Thea, our economic background, or even as early as the Kink demand curve would have suggested there could be asymmetry in the buying prices, because according to the Kink demand curve, when prices are raised, competitors may not follow, but when they go down, competitors would follow. We also know from microeconomics that being a very what do you call this homogeneous product, no oil products, they're generally highly substitutable. So one would expect the law of one price to prevail, the law of competitive markets, that competition would compete prices to the same level. But also other industrial organizational theory models of, let's say, like hoteling and location models suggest that, well, you can have some differences in prices due to location and other cost difference perhaps. But that's in great part, I guess, what motivated our interest to see, well, is there a difference? Has there been differences in the dispersion or the spread of prices, when the oil prices have been changing, especially when going up as against going down, because a wider dispersion of oil prices might suggest that there is less competition, because as we point out, the most familiar model in microeconomics about market structure, the competitive market, would have suggested that for homogeneous or very similar goods, there shouldn't be too much difference in prices, not too much variance or dispersion in prices. Okay, next slide. So I will at this point, my co-author, Thea, will now come in to talk a bit more about the empirical methodology, data, and how we work with it to get our findings that we will report later. So thank you, Thea. It's your turn.
Thank you, sir. Okay, so we revert back to our research question. Is there a relationship between the price changes, that is, price hikes and rollbacks, with the variance or the spread of local pump prices in the metropolitan areas of the Philippines? So this question will be answered in two parts, complementing the two objectives that Dr. Yu has discussed earlier. The first objective of analyzing and observing the patterns and volatility of petroleum prices was carried out through the computation of the standard deviation. To meet objective number 2, which focuses on the relationship between the weekly adjustment of prices to the corresponding price dispersion, we carried out a simple regression analysis that examines the relationship between price changes, price increases, and average prices to the corresponding level of variance. So here we show the three primary regression models that we use. Equation 1 regresses the variance on price increase and average prices. Equation 2 regresses the variance on price decrease and average prices, while equation 3, which puts together the first two equations, regresses the variance on the dummy variable, the absolute value of price change, dummy interacted with the price change, the average price, and the dummy interacted with the average price. The interaction with the dummy variable is used to identify observations that are characterized by a price increase. We now proceed to the next part, where we present the results and analysis of the data. So for the data that was used for this study was from June 11, 2019 to March 8, 2022. These were retrieved from the DOE's website and was the available data at the time of the writing of the thesis. In these data sets, prices were indicated weekly for all gasoline brands that were available in each city. We note that some weeks are without data from the DOE, thus the varying number of observations per area. To gather insights for the first objective, we divided the data into 4 sub-periods. This should give a descriptive situation of the retail pump prices before the pandemic, that is June. We specified it as June 2019 to February 2020. During its onset, March 2020, throughout its course or mid-pandemic, and finally during the new normal or the recovery period. On to the first set of the results on the pricing patterns. We summarized that the trend of average prices throughout the entire period of study is similar across all the petroleum products, RON 91, RON 95, and diesel, for the 4 cities included. No single city or product was spared from the effects of the pandemic, with each one going through the same abrupt dip in prices between the first and second periods, then a gradual increase in average prices during the third period due to the reopening and recovery of the economy. And then by the fourth period, we observed that prices shot up higher than pre-pandemic levels. given the effect of global events at the time, specifically the war in Russia and Ukraine that affected the global oil supply. In terms of volatility as measured by the standard deviation, it is evident that in all areas and products under study, the volatility of prices significantly increased at the onset of the pandemic, comparing the first period to the second period. By the fourth period, it is obvious that volatility has significantly increased in the new normal compared to pre-pandemic levels. This signals that during the pandemic and in the new normal, petroleum prices would tend to fluctuate more. The following slides will show a summary of findings from the regression analysis. This part will only include the results for RON 91 in the 4 cities included, as the regression models for all 3 products reflect similar findings. The first statistically significant result is reflected for price increases and price decreases, wherein both have a negative significant relationship with the variance, given the negative coefficients of 1.48 and 0.949 respectively. On the other hand, it is noticeable that in all 3 equations for RON 91, the average price has a positive relationship with the spread of prices. Moving on to the regression models for Baguio City, we see that only price decreases are significant, resulting in a positive coefficient of 2.422. For Cebu City, only the average prices for RON 91 resulted to be statistically significant with positive coefficients. And then for Davao, the same is true, wherein only average prices are statistically significant with a positive relation to the variance. The last few slides show a summary of the results for RON 91, RON 95, and then diesel. The results are focused on for RON 91 only, since again, the 2 other products also reflected similar results. Finally, we move on to the summary of this presentation. So in terms of price patterns and the fluctuation of prices, we saw that average prices dipped during the onset of the pandemic, and since the reopening of the economy, these prices have been continuously rising given the economic recovery and other global events that affect the supply of oil. We have also observed that petroleum prices have tended to fluctuate more in the new normal. Furthermore, given the regression results, we summarize by saying that there is no overarching pattern that relates the variance to price changes and average prices across all cities. While in some results, average prices have tended to have a significant and positive relationship with variance, it was not also a common result in all the regression models. So while this investigation did not come up with that single overarching pattern that we were supposedly looking for, it is also a good discovery that neither price increases nor price decreases cause a significant effect on the spread of prices, at least based on this study and the data used. With that, we end our presentation. Thank you.
All right. Thank you very much for your very interesting paper and for keeping your presentation within the allotted time. We now move on to the next paper from our colleagues from the Department of Science and Technology, with the paper titled Assessing the Vulnerability Factors Affecting the Economic Losses from Natural Disasters Using a Spatial Autoregressive Model in the Philippines. Now, our presenter is Mr. David Abines. You have the floor now.
Am I loud and clear?
Yes, very
All
loud
right.
and clear.
Thank you so much, Dr. Cuevas. So good afternoon to everyone. So I am David Abines of the Department of Science and Technology, Region 11, and it's my pleasure to present to you the results of my study entitled Assessing the Vulnerability Factors Affecting the Economic Losses from Natural Disaster Using Spatial Autoregressive Model in the Philippines. So this will be the outline of my presentation. So as we all know, the Philippines is located in a disaster-prone area, The geographical location of the Philippines makes the country uniquely exposed to an extreme disaster, including recurrent tropical storms, earthquake, active volcanoes, are among others. With the socio-economic environmental condition of the country, we have experienced huge economic losses due to natural disaster. It can be noted that the impact of the natural disaster can be severe in terms of social, economic, environmental aspect. For social impact, we can cite some of those evident negative impact, such as the damage in infrastructure, such as the bridges, telecommunication, road, electricity. There are also negative impact in terms of economic aspects, such as the destruction of assets like agriculture and production of livestock. While in environmental, damage can be resulted from a decrease in forest land due to a shaping of entire landscape. So just to give you a brief background, based on the historical data from 1993 to 2020, typhoons and floods have been the most frequent occurring disaster in the Philippines. Based on vulnerability studies, the most vulnerable region to typhoon in the country is the National Capital Region, the Southern Tagalog Region, Cagayan Valley Region, Central Luzon Region, and the CAR region or the Cordillera Administrative Region, also Bicol Region. While Visayas and Mindanao are likewise becoming more at risk due to an increasing number of tropical cyclones entering the southern part of the country. As mentioned, Philippines is located in disaster-prone areas. This situation brings many potential factors that could contribute to disaster, such as high population density, overcrowded and unsafe living environment, pollution, garbage, hazardous industries, underdeveloped and complicated lifeline system, environmental deterioration, poverty, and inequality. All these factors make the country vulnerable to disaster. Reducing disaster vulnerability is recognized as more direct and effective way to mitigate natural disaster risks. It is expected that a careful analysis of disaster vulnerability from a spatial or geographical perspective will help in improving disaster preparedness as well as facilitates both immediate and long-term recovery. That is why the general objective of this study is to identify several significant factors associated with damage resulting from natural disaster. Specifically, we want to present the thematic map of economic losses from natural disaster by provinces, present the thematic map of vulnerability factors in terms of social, economic, and environmental aspect that would affect the economic losses from natural disaster by provinces, and also to determine the vulnerability factors affecting the economic losses from natural disaster in 2018. These studies anchors to the concept of vulnerability in the social framework of COLIF. It allows the researchers to explore the key role and socioeconomic factors in creating a weakness in responding to and recovering from the effect of extreme natural disaster. This study identifies different vulnerability dimension to social dimension measures, the sensitivity of population to natural disaster, and its ability to respond, prepare, cope, and recover from hazard events. Besides, of the economic and environmental dimension are also important in analysis of the vulnerability. This theoretical framework of this study provides an overview and complexity. This focus on three dimensions, as mentioned, the social aspect, economic aspect, and the environmental aspect. The dependent variable of this study is the economic loss in terms of natural disaster, which measured the total economic damage by provinces from natural disaster in the Philippines at 2018. At the same year, the independent variable are the 6 vulnerability factors clustered into 3 specific groups, the social, economic, and environmental. So there are 2 social indicators for social factors, which are the less educated people. It is measured by the percentage of population without elementary school education. Also, a number of hospital beds in health institution per 10,000 inhabitants as proxy an indicator of infrastructure. And also, there are 2 indicators for economic aspect. First is the statement of receipt and expenditure per capita as proxy of the gross provincial domestic product. Second, the agricultural production in the provinces measured in terms of volume of production of palay and corn in the provinces per metric tons. While for environmental aspect, which are precipitation, is measured as the average precipitation in millimeter in 2018, while the second indicator is the extent of open space, refers to the forest land as percentage to the total land. This study employed thematic analysis to depict data with allocation to identify spatial patterns in trends. The spatial analysis was used to investigate spatial effects. This is an estimation and inference method for models which the individual outcomes depend on each other. This analysis intends to examine the spatial dependence between the observations. The provinces of the Philippines serves the spatial units of this study. By this, it is examined the spatial dependence of the provinces by its neighboring provinces. So for the results, Figure 3 shows the economic losses in terms of agriculture and infrastructure losses that resulted from natural disaster in 2018. It was found out that there were 21 typhoons entered in the Philippine area of responsibility, on the same year of which 8 made landfall and 5 of these were tropical depression. Notable was Typhoon Umpong, which hits the northern and central Luzon. This resulted to a major economic loss in terms of agriculture, infrastructure, and other private damages. With a total of 50 billion peso damages, those provinces situated within northern and central Luzon have been heavily affected by the above-mentioned typhoon. Majority of typhoon have devastated the country were characterized by heavy and prolonged rainfall, affecting 38 provinces which suffered repeated displacement. Succeeding thematic map shows the status of provinces in terms of those vulnerability factors affecting the economic losses from natural disaster. This study considered 6 vulnerability factors. Of all these factors transpired into 3 vulnerable dimensions, which are the social, economic, and environmental vulnerability. So first, for social, we have the basic literacy rate of population of 5 years old and over without elementary school completion by provinces. That's why this is one of the social vulnerability factors. This shows that among the regions, National Capital Region had the most residents who are literate with 60.8%, followed by Region 1. Meanwhile, 15.4% from all provinces in Bangsamoro region in Muslim Mindanao who are at least literate even without no elementary school completion. The map implies that those metropolitan areas in the country have easier to access education than those who are considered poor provinces. For another indicator is for social vulnerability is the bed in health institution per 10,000 people. The map revealed that the National Capital Region has the greatest number of beds in health institution per 10,000 people. Meanwhile, most of the provinces with limited beds with their health institution per 10,000 are those critical provinces such as the Caraga, the Baarm region, the Northern Samar, and the Eastern Visayas region. Now for economic vulnerability, based on related literatures, agriculture in the country plays a vital role in economic activity. Thus, this study considered agriculture as one of the vulnerability factors. Figure 6 shows that the majority of production of palay and corn are located in the province of Northern Mindanao, Central Luzon, and some provinces in Cagayan Valley region, such as the province of Cagayan and Isabela, while other provinces has limited volume of production of palay and corn. In Figure 7 shows the thematic map of gross provincial domestic product of each provinces. This is proxied by statement of receipts and expenditure per capita in terms of peso in 2018. Top 10 among all provinces who are high in terms of generating income are the province of Ilocos Sur, Metro Manila. Some provinces of Calabarzon has the largest GDP per capita among provinces with a total of 28% share from the total GPDP of all provinces of the country. While most of the provinces in Bangsamoro, province of Zamboanga, Eastern Visayas got the lowest share of the total GPDP with only 6% of the total GPDP in the country. Now, for the case of environmental vulnerability, Figure 8 shows the percentage of forest land by provinces. The thematic map shows the province of Palawan, Bukidnon, Davao Occidental, Negros Oriental, and some provinces in Cagayan Valley region are saturated with forest land. Meanwhile, the Metro Manila and most of the provinces in Calabarzon and some provinces in Eastern Visayas has limited forest land. This implies that protecting the environment could reduce disaster risk by enlarging preserving forest land with function as a buffer zone. Now, For another indicator for environmental dimension is the precipitation. The map shows that the province of Eastern Visayas region, Bicol, and some provinces in central and northern Luzon has frequent precipitation. This implies that those provinces are most frequent visited by heavy rains, given the most of trajectory of all typhoons have frequently passed through on these areas. Meanwhile, those provinces in Region 12, Region 11, and Region 10 are those areas with minimum frequency of precipitation. This can be observed because typhoons are not frequently passing through these areas. Now, for spatial analysis, global Moran's I applied to assess the spatial distribution of the model residual in 81 provinces. The value of global Moran's I was calculated using contiguity-based approach to define the neighbors of spatial unit. This study used Queen-based contiguity approach, assuming that all adjacent provinces are considered neighbors. After the consideration of scope of such neighbor, this study identified this presence of spatial autocorrelation. The results of Moran verified that the datasets have statistically significant spatial autocorrelation. Now, these are the estimation vulnerability factors. The result of spatial analysis showed that out of 6 explanatory variables, there are only 3 significant factors, which are positively related to disaster damage at 5% level of significance. The coefficient of explanatory variables show their relationship towards the dependent variables. On the economic aspect, the coefficient of agriculture and positively related to the disaster damage, along with the previous study showing that the agriculture suffered severe disaster damage by having a loss of production due to natural disaster. This would affirm the conclusion of Holland that those in primary sectors, particularly the agricultural sector, are more likely to be affected adversely by natural disaster. People engaged in agriculture may be more vulnerable because of their lower income and higher dependence on resource extraction economies. A large number of agriculture provinces in the country indicates higher economic vulnerability. While for environmental aspect, precipitation is positively related to disaster damage. Results show that disaster damage is more severe in provinces where annual precipitation is high and natural disaster happen frequently. For social dimension, less educated people are positively related to disaster damage. This would provide similar result with the related literature that provinces with large portion of less educated people tend to be more vulnerable to natural disaster because they seem to have less physical and mental capacity to cope with them. The regression results show that, in summary, the disaster damage is more severe in the communities where annual precipitation is high and natural disaster happen frequently. So the more communities with a higher precipitation sector from agriculture and less educated people, those provinces are exposed to economic losses from natural disaster. So this study would recommend that the findings of this study have value for policymakers who are developing vulnerability reduction policies for population and places considered at risk. Based on the results and findings of this study, the following are recommended. First is protecting the environment could reduce disaster risk by expanding forest land buffer. Also, we want to intensify disaster awareness, particularly those who are vulnerable to disaster. For instance, those who are considered less educated and low-income household. Also, we want to review and calibrate policies that would ensure inclusivity and effectiveness in responding disaster. We provide access to critical resources like emergency information and material to those vulnerable sectors, such as agricultural sector, that should be highlighted in emergency management and planning. And that's all. Thank you.
Yes, thank you very much, David, for that very good presentation. Now we move on to the third paper, which is very much related to the one presented by David. This is an analysis of the economic resilience and vulnerability of local economies in the Philippines. May I call on now Mr. Jerwin P. Enerlan of the University of the Philippines, Visayas, Tacloban College.
Okay, wait. Okay, wait. Share screen. Yeah. Yeah. Okay, so good afternoon, everyone. Yeah, okay. So I'm going to start discussing about an analysis on the economic resilience and vulnerability of local economies in the Philippines. This is my master's thesis. My advisee is our moderator, Professor Agam Cuevas. So based also on the background of the study, it is because that the Philippines is highly vulnerable to weather-related disasters, or commonly called as hydrometeorological disasters. It tend to have localized impact on the region or the province in the country. Therefore, this study focuses on the characterization of economic resilience and vulnerability of the regional administrative economies at the regional level in the Philippines. The reason why we are using here economic resilience rather than resilience is to provide a specific understanding on what aspect of resilience are we trying to understand here. So according to the World Bank report in 2010, most domestic economy were geared on ramping up spending in the economy to increase productivity. However, external factors such as disasters tend to uh, impact or negatively affect the growth of these countries, especially large-scale disasters. So most of these external shocks can be political upheavals, foreign interventions, mismanaged debts, internal conflicts, and natural disasters. So one author, Brigolio, said that economic shocks to countries are dependent on the existing economic structure, and most of the developing countries are identified having high economic vulnerability. So, however, despite the high economic vulnerability, Bergoglio also believed that a country can be resilient or have high economic resilience in order to determine the economic resilience of a country. Therefore, a composite index can be used to characterize both economic resilience and vulnerability of different countries. Resilience and vulnerability were used by most studies to determine whether there are factors that minimize or magnify the impact of disaster, which is the main point of this study. And vulnerability are usually used by some studies as the factor that determines resilience or susceptibility to disaster. However, the argument of this study is resilience is different from vulnerability. It is the same coin, but a different side of a coin. So there are authors that also identify vulnerability as a factor that increase disaster risk. But vulnerability can also be identified as economic issues, poverty, food security, and etc. Okay. Uh, Therefore, in this study, economic resilience are factors that can be readily influenced by government policies like income, education, healthcare. Vulnerability, on the other hand, are factors identified based on permanent or semi-permanent characteristics, such as frequency of disaster, average rainfall volume, forest cover, and population density. Therefore, the study aims first to measure the economic resilience and vulnerability of the regional administrative economies in the Philippines through a composite index. Second is to determine how the identified economic factors and vulnerability factors affect the impact of hydrometeorological disasters on local economies. And third, to assess how the economic resilience index and vulnerability index may contribute to policy formulation in relation to increasing economic resilience against hydrometeorological disasters. So we are using here a framework called the local economic resilience process. So according to the local economic resilience process, an economy starts from a pre-shock growth, and then there are inherent and inherited factors such as inherent economic dynamism, economic openness, sectoral structure, and other socioeconomic variables. And then this growth or this trajectory of an economy is affected by external shocks. So these shocks is the impact of this shock is dependent on the depth or the magnitude of these disasters. And therefore, in order for an economy to recover, it depends on the adaptability of that economy in order for that economy to recover losses from a particular disaster. However, the argument here is that this framework does not believe that we are going to go back to an original growth path, but rather we are going to change our growth path at a higher level or at a lower level, therefore talking about resilience. Okay, so the conceptual framework used in this study is that economic resilience and vulnerability factors affects the impact of disaster. So most of the study that we know looks at the impact of how a disaster affects these particular socioeconomic factors. However, this study do the different perspective. So now we are looking at these socioeconomic factors as the one who affects the impact of disaster. So this study made use of several data. So we got average family income, average family savings, education cohort survival rate, number of health professionals, government revenue, ownership of living place, house material, electricity, connectivity, and access to drinking water were sourced from the Philippine Statistics Authority, both from the FIES and the APIS, and also data sets on disaster, frequency of disaster, mortality, affected individuals, and monetary damages were all from the EM.cred. And the rainfall volume data set was sourced from PAGASA. And also the primary forest cover was sourced from the Global Forest Watch. Okay, so to calculate the composite index, all variables first were standardized or normalized using this equation, where x and t is the standardized or normalized value of the factor for province n at time t, and xt is the factor's value at time t. So we have a minimum and maximum we set. So it depends. It can be based on the availability of the data set, based on a standard set by a particular institution. But most of our data that were used, we used we selected on what particular minimum and maximum value can be used. Okay, so for the composite index, the resilience index or the economic resilience index is the summation of all the normalized value times a particular weight. And the vulnerability index is also a summation of the vulnerability, the normalized value of the vulnerability factors times a particular weight. Okay, so one important variable that we are using in this study is what we call the life year index, which was created by Noy. So this is by Ilan Noy in 2014, which is based on based on the WHO life years index. So the equation here tells us that L as a function of mortality, average death, and average age expectation is the number of years lost due to event mortality or when a particular disaster happened, calculated as the difference between the age of death and life expectancy. IN is the cost associated with the people who were injured or otherwise affected by the disaster. And damage is the measure that attempts to measure the damages of properties, capital assets, and infrastructures into life years. So we are using here a matrix wherein this matrix will characterize the composite indices that we calculated. And here we have here our panel data, wherein our dependent variable is the disaster adjusted life years index, and then our independent variables are average family income, average family savings, health, ownership, education, all the variables that were mentioned earlier. Okay, so for the panel data analysis, a balanced panel data was used. Considering that there are missing values in some of the data sets, mean imputation was used. So mean imputation may not be the best method in filling up for the missing data, but it will be sufficient in order to help in determining the relationships of the independent variables and dependent variables. Okay. So because of the socioeconomic variables are used in this study, multicollinearity will be present in the model. So also to determine whether we are going to use a fixed effect or a random effect model, we are going to use the Durbin-Wu-Hosman test. Okay, so a Bruch-Pagan LM test is also conducted to determine whether random effect model or pooled OLS is appropriate to be used. So we have here a summary statistics of the regions, the regional summary statistics for each independent variables. So as you can see here, in terms of the impact of disaster, region 4B has the highest life years lost in relation to disasters from 2000 to 2018, and ARMM or BARM has the least life years index life years lost. And then in terms of income, NCR has the highest level of income, and then the lowest level of income, average family income, is ARM and BARM. So for family savings, NCR also has the highest, and the lowest is in ARM or BARM. And then for the educational, for education as a socioeconomic variable, we use educational cohort survival percentage as our proxy. in terms of education. So Region 2 has the highest education core survival, and then ARM or BARM has the lowest education core survival. So for the number of health professionals, for health, we use the total number of health professionals. The highest number of professionals can be found in NCR. ARM and BARM has the lowest number of professionals. For local government revenue in thousands, NCR has the highest local government revenue, ARM or BARM has the lowest. In terms of the regions with the highest sturdy housing materials, CAR has the highest ratio of households with sturdy housing materials, and then Region 6 has the lowest. For ownership of living place, Region 2 has the highest ownership of living place in terms of ratio, and Region 6 has the lowest. Okay, for electricity connectivity, NCR has the highest ratio of 99, and then ARM or BARM has the lowest ratio of electricity connectivity. In terms of access to drinking water, NCR has the highest, and then ARM or BARM also has the lowest. And then frequency of disaster, Region 3 is the most frequently affected by major disasters. When we say here affected, that disaster should really have impacted that particular region. So it doesn't matter if that disaster happened only or entered PAR, but as long as that disaster or that storm did not enter that particular region, then it is not calculated here. And then for the lowest number of disasters that happened there, it is Region 9. And then for average rainfall volume, CAR has the highest rainfall volume in average in millimeters. And then Region 7 has the lowest. For population density, definitely NCR has the highest population density and CAR has the lowest. For the forest cover, NCR has the lowest forest cover in hectares, and Region 4B has the highest forest cover. So these are the calculated resilience index, but we are going to characterize them through a trend and through a matrix. So this is the matrix that was shown earlier. So we have here the orange line, as you can see, is the average vulnerability index, in which it is the total, it is the average vulnerability index coming summed up from the total vulnerability index of all regions divided by the number of regions. And then we have on the gray line, the horizontal gray line, is the average economic resilience index. So through this matrix, as you can see, in 2000, NCR is situated in a self-made quadrant, or when we say self-made quadrant, NCR can have high level of vulnerability, but also a high level of economic resilience. And in terms of the lowest economic resilience, ARM has the lowest economic resilience, but also a very low level of vulnerability. And other regions are somehow situated at the middle of the intersections of these two averages. Okay, so for 2003, it almost have the same setup: NCR, vulnerability, and high economic resilience. In 2006, NCR again has a high economic resilience, but high vulnerability. The same with ARM, low economic resilience, low vulnerability. And then in 2009, NCR, high economic resilience, ARM has low vulnerability. So overall, until 2018, these two regions are situated almost in the same quadrant. But what's important here is that we can see that there is somehow changes on the economic resilience and vulnerability of every region. And what we are trying to paint here is that despite identifying a region as very vulnerable, it is not impossible for a region to improve its situation. Okay, so yeah. So we have here a trend, the trend of the economic resilience and vulnerability index. As we can see here, NCR, which is the first column, has high level of economic resilience, but as you can see, throughout time from 2000 to 2018, nagdi-decrease yung the economic resilience starts to decrease, and also the vulnerability index somehow is have a decreasing trend. And then also for other regions, as we can see, in Luzon, Dakar, Region 1, Region 2, Region 3, 4A, 4B, and Region 5, most of them shows that they have an increasing economic resilience from 2000 until 2012. However, later on, their economic resilience started to decrease. But as you can see, the vulnerability index by also of most regions starts to increase at certain points, especially from 2003 until 2018. Okay, also for Visayas, as we can see here, Region 6 has a high level of economic resilience in comparison to Region 8, but also as we can say in their vulnerability index from 2000 to 2018, it starts to increase. And also for Region 7, in which Region 7 has the highest economic resilience among the regions in Visayas. In Region 8, you can see that in between 2012 to 2015, this is the time when Yolanda happened in 2013. Despite the impact of Yolanda, which should have resulted to an increase in vulnerability, we can also see that the economic resilience of Eastern Visayas also increased in that time. Okay. Okay. Sorry. Okay. So for Mindanao, as we can see here, the economic resilience by most regions have an upward trend, but also the vulnerability index also has an upward trend for most regions. And BARM has the lowest economic resilience and the lowest vulnerability index. Okay, but also as you can see, with the exemption of BARM, BARM is the only region in which from 2012 to 2018, the economic resilience started to increase. However, the other regions, as shown also in other major islands, that the economic resilience started to increase at a certain point, especially in 2012. Okay, so this is a map showing so that we can identify whether the relationship, the possible relationship, or we can characterize how every region may have a spillover of the economic resilience or the vulnerability that they experience. As we can see here in 2000 until 2003 for the Luzon area, NCR Region 4A, Region 3 has the highest level of economic resilience, but also those regions experience high level of vulnerability. But as we can see, if for Region 8, no, okay, so for Region 8, this one, it has a low level of economic resilience, but also a very high level of vulnerability. Okay, so overall, most of these maps also show the same setup, but it can be hypothesized here that there might be really an effect on whether the geographical location of a particular region can affect the economic resilience or vulnerability of other regions, especially if there are no great distance between them. Okay, so for the panel data analysis, okay, so we did a multicollinearity test, and we identified that the average family income, electricity, and government revenue has high level of multicollinearity. Therefore, they are removed from the model. So also, we did a Durbin-Huisman test, and then we identified that for the model, the fixed effect model should be used for the panel data. And then we also did a Bruch-Pagan Lagrange multiplier test, and we have seen that pooled OL random effect is a much better model than the pooled OLS. However, to confirm what particular model we are going to use, we did a the Bruch-Pagan test. Okay. So, however, because based on the Wald test, the fixed effect model is more fit than the pooled OLS, we proceed on using the fixed effect model and analyzing the panel data. Okay. So, for the panel data, the results showed that for the fixed effect model, in which this is only our focus, average family savings, access to safe drinking water, frequency of hydrometeorological disasters, rainfall volume, and forest cover have significant positive relationship with the impact of disaster. Okay, so the possible reason here, as also done by other studies, is that by Masozera and De Silva, they found that income also has shown a positive relationship with the impact of disaster. The possible explanation is that, of course, when a disaster happens in an area with high economic level, there are more damages that can be experienced. Okay, so the same thing with access to safe drinking water. If we have a more developed water utility system, therefore, if a significant disaster happens or a major disaster happens in that area, more damages will be experienced. And then for frequency of hydrometeorological disaster, it really proves that the more frequent the disaster happens in an area, the greater the damages that can be experienced. And for the rainfall volume, it also showed a positive relationship. The same with the forest cover. So in conclusion, economic resilience and vulnerability are two important indicators on how regions in the Philippines can minimize or magnify the effect of hydrometeorological disasters. So yeah. So recommendation, I think I'll just go on that. Maybe it's important for studies on economic resilience and vulnerability be focused on provincial level with a complete data set, and also use more complicated econometric techniques be employed to ensure reliability of the result. Okay, that's it. Thank you.
Okay, thank you very much. We now move on to our question and answer portion. I would like to request everyone who would want to post their questions to put them in the chat box. Please identify yourself and your affiliation and to whom you are addressing the question. Are there questions now in the chat box? I don't see. Are there questions? Still quite early. It's just 1:56 p.m. Any questions? Let me first, since I'm the moderator, maybe I can ask some questions to Dr. Peter.
Yeah, hi.
Yeah, hi.
Hi.
What's the what is the possible implication of the results of your study to in relation to the level of competition on our petroleum industry?
Well, there doesn't seem to be a parang common, I mean, as they are shown in the regression results. There was a statistical significance between the price changes in the variances. Now, if we accept that an increase in variance is parang possibly an indication of less competition, because if there was competition, you would expect prices to sort of be more narrowly
Convergent,
convergent. So mukhang there was no statistical relationship naman, no? At least not significant in most, if not all, of the cities, I think. Mainly what happens, and this was not also universal, yung statistical significance was more of in relation to the price level. So, you know, the average price level of a city rather than the changes. So, you know, but although I think just doing also, I think there was a table we showed of the variances in prices of the different cities. Mukhang there was an increase though in the standard deviation of prices, no? In I think all the cities in towards itong latter part of the data was divided into 4 periods. So that's interesting. We're not sure we have an explanation for the increase in variance, except that perhaps although nagre-recover yung economy, perhaps certainly in the earlier parts of the pandemic, there was not much traveling, and so
Yeah.
maybe there was not much demand, which may contribute to although one can argue then with the smaller demand, you might have more competition then by the sellers to compete for the smaller. So I'm not sure. It can go both ways. So, but price changes does not seem to have a statistical correlation with a significant one with the price dispersion. So, at least on that score alone, yung price changes, they don't seem to have an effect on variance of prices, on the spread of prices.
Thank you. Another question. Why is it that we adjust our prices every Tuesday?
Yeah, it seems kasi naging practice because of going through some of the older news stories. Parang there seem to have been and the prices are more or less, the adjustments are more or less the same. So I think one newspaper man was I think this is what's his name again, yung fellow who often reports on the price changes. It's because yung the process of calculating yung change in price is based on the change in the maps from one week to another. So for example, kung ano yung adjustment this week, like last Tuesday no nag-adjust, is like ano yung percent change ng prices last week from 2 weeks ago, of course adjusted na with the exchange rate to get into the pesos, to get the percent change in pesos. And so that's the one for that's going to be the change for this week. So since they're getting it week by week, so they have to wait till the Saturday para ma-complete, I think, yung average for that week. And then so Monday nila, I guess they come back to the office. Yung mga oil companies, they do the computation. So so by Tuesday is when they adjust their price. I think they all have to notify the DOE also. So parang baka naging convenient yung, since it's a week to week change.
Yeah.
And then Monday is the first maybe working day of the week. So they all do that computation on Monday and then they adjust on Tuesday. So
That's quite interesting because I often get asked why they adjust it during Tuesdays or every Tuesday. Anyway, thank you very much, Dr. Peter. So are there any more questions?
Dean,
Yes, okay. We have one. Okay, I will entertain now from Zoom. Mr. Villanueva, yes, are the questions?
sorry. On the economics of disaster, my initial question really was about the paper. We're gonna get the paper because personally I'm interested in the paper. By the way, I'm from UP Los Baños. I'm teaching money in banking, but I was a former chief risk officer from the industry. I'd just like to comment that I actually like the paper of Mr. Jerwin Inerlan, and I found it online now. Just like to make the comment that in the industry, there's actually a use for this one, and we need those indices and indicators to measure risks, how the disaster risks are being translated into financial risk. That's a real need in the banking industry right now. So thank you for this paper, and maybe I'll get in touch with you, Jerwin, just to help out on this one. There's a real need in the banking industry. The bankers are struggling with this because this is really on the natural sciences side. So thank you for this indicators. I just want to make that comment.
Actually, I need to submit the revision to the journal this Saturday.
Okay.
So, yeah.
So you can wait for the published paper.
It's very useful. Thank you.
Thank you, sir.
Okay, thank you very much. So are there any more questions from the floor, from our Zoom room? So, let me call on the Secretariat, Miguel. I guess there aren't any more questions, so can we now conclude the session?
Yes, sir. If there are no more questions, we can conclude the session.
Okay, so since there are no more questions, I would like to thank everyone, especially our presenters, Dr. Peter, Mr. Reese, and of course, David and Jerwin, for very wonderful papers. And thank you everyone for attending this session. And hopefully we can see you again next year for another round of papers for the 61st, okay, the 61st PES conference and meeting. So thank you and good afternoon.
Thank you, Dr.
Thank you.
Cuevas. Good to see you again. Hope to see
Good
you
to see you
all
also.